Hey coders, how's it going guys? So today actually we're gonna look at gradient descent and linear regression. So we're gonna try to train the linear regression model using the gradient descent approach. So the first thing to start with, we're gonna import our necessary libraries. So I'm gonna import torch and I'm gonna import numpy as np. So we're gonna try to do this from scratch as possible. So the first thing that we're gonna do is that we're gonna have to come up with our own data set. What's on my mind right now is that let's say we want to predict like some sort of like an item, right? Maybe we want to predict like the demand or probably sales or something like that. So I came up with this dummy data set here. We can think of it as like we have months, economic status, and weather. I came up with this, so let me just explain them to you. So this is gonna be the month, and this is gonna be economic status. By economic status, I meant if it's less than 50, it's like going towards recession. If it's like greater than 50, we can think of it as going toward prosperity. Economic is doing fine, something like that. Then when we think of weather, we can think of it as it's hot, it's cold. So anything that is less than 50, we can think of it as cold, and then anything that is greater than 50 is like hot weather. So I try to kind of like map these to make kind of like create this fake relationship so that we can create a proper data set on our model. So these we're gonna predict like sales of shirts and sales of jackets, okay, based on this data. So I'm from South Africa. So when it's around June or mid of the year, it's usually cold. So that's why here you can see that okay, when it's probably 6 or July 7, the weather or the temperature is gonna be low. So when it's January or December, that's when like the temperature is high. So also like there's this impact of like recession or so-called economic status that we created. So it's going to actually impact also the sales. Okay, so that's what we have. It's a small data set, but the main goal is to learn the power of calculus and how it's helping us to train linear regression. So we just need to convert this data set into torch tensors. So some of you might be asking yourself why we have to do this. It's because like the main two reason is because we can actually we can train our machine learning models using GPU. So another thing is that torch actually allows us to have the concept of gradients, to compute gradient, I meant to say. So that's why we have to convert our numpy array to torch. So for now, we're gonna say torch from numpy. So I'm just gonna take all of these arrays that we had and I'm just gonna convert them to numpy. So I'm just gonna say torch. I'm gonna do the same thing for output, which you're gonna say torch dot from numpy. We're gonna take the output, I meant to say. Cool. The second thing that we're gonna do, let me see, I think I made a silly mistake. Cool. So the second thing that we're gonna do is that we need to calculate their weights and biases. So if we need to calculate linear regression, what we need to do is that we need to take inputs and do a matrix multiplication against the weights, and we're gonna add our bias. So that's all is in it, right? So the only thing that's left is that we need to now initialize the weights and initialize the biases. So let's initialize the weights, right? So I'm not sure how familiar you are with deep learning. So what we're trying to do is that first thing that we do is that we try to initialize weights and biases randomly. Then what's going to happen is that during training we will be actually updating these weights and biases. So this way we just want the weights that minimize the loss. So but whenever we start, we're just going to randomly initialize them. So what I'm going to do is that I'm going to say weight equals to, still using torch. So we're just gonna say torch, and you're gonna use the random function, and we're gonna create 2 by 3 matrix. Then we're gonna say requires grad. So I'm gonna explain the concept of gradient in more detail. Just stick with me for now. We're gonna have bias. Also, we're gonna randomly generate the bias because we have 2 outputs. So what we need to do is that we need to have 2. So it's going to be a vector. Then we're going to say requires grad. We're going to say true also. So kind of like give you a glimpse of randomly generated weights and bias. This is what we have for now. Cool. So now that we know the formula, which is inputs, then we do matrix multiplication with the weights, then we add bias. So that's all. That's what we need to do, right? So before we start, with like whenever we're doing like matrix multiplication, is that it's important that your column and your weights dimension they match. Meaning that if now we can take a look at the weights, we will see that the weight has 2 by 3 dimension. So this will not work if we do a matrix multiplication with our inputs, because if you can remember, our inputs has the columns of the dimension and the columns is 3. So we need to then transpose the weights. So meaning that we need to turn the weight rows to be 3 so that they can match the column here, if that makes sense, guys. Okay, so what we're gonna do is that we're gonna use this add symbol, which denote a matrix multiplication. Then we're gonna take the weights, then we're gonna transpose them. So this, actually, let me show you with an example. So this will essentially transpose our weights. As you can see, it's been transposed. So we had something like this. So where we had 2 rows, right? Now we have 3, but 2 columns. Okay, simple as that, guys. So the thing that we're gonna add now is bias. Okay, so now we're supposed to get predictions. Oops, I think it's B. Yes. So cool. It says expected scalar type long but found float. So this is a problem because it looks like when we initialize our data, we initialize it as int, but we're supposed to actually initialize it as float. So this is quite important that you say d type equals to float dd2. Similarly, you say d type equals to float dd2. Okay, so now I think everything should work as expected. Just gonna make sure everything is there. Then now we're gonna get our predictions. Look at that. We get our predictions, but look at how off they are. So here it says shares it's 52. What was the actual number? It was 40. So you see it's still off, but we're kind of like looking at it. Obviously, we're gonna have to calculate a loss function to see how off we are, but this is a good start. We have initialized our weights randomly, so we don't expect our model to be that good. So we need to train it. Now that's where we're gonna get into concept of gradients and backpropagation algorithms and such things. A function that actually can give us the predictions, right? So we can call this function model. So it's gonna take the inputs and it's just going to return the inputs matrix multiplication weights dot t, then we're just going to add the bias. So we're just gonna do that, and all the time, every time we call this model, we're gonna get the predictions. So we can have something like model inputs and can have predictions. Okay, so these are our predictions. So we know the actuals, and we call them outcomes. So we can actually compare them to see how off we are, but this is not ideal, right? You want to use maths to calculate the difference of this. So we're gonna use mean squared error, MSE, right? We're gonna use mean squared error to calculate as our loss function. Okay, so the goal here, I'm just gonna write all the steps. So the goal here is to kind of like calculate the difference between the two matrices of threats and outcomes. Okay, then after you're done, what you need to do is that you need to square the differences. Oops. Okay, then you need to calculate the mean, then you're done. You can, to remove the effect of the squaring so that you can get the actual value, you can also use the square root. Okay, so we need to create a function which we're going to call MSE. So the function is going to take the predictions and it's going to take the outcomes. Okay, then the first thing we do, just like we said on that, we're going to calculate the difference. So to calculate the difference, we're just going to say predictions minus outcomes. Then when we're done, we're just going to say return. So to calculate, to square the values, we can just say difference times difference. Then to calculate the mean, we can just say torch dot sum, because we're gonna need the total of the elements. We're gonna do something along the lines of div.numel, I think. Yeah, and this will be our function. This will be our loss function to calculate how off our predictions are. Remember that the goal is to make sure that we have a small loss, so this will be a very a helper function. So now that we have a loss function, so we're just gonna compute our loss, kind of like understand how off our model is. So I'm just gonna say preds and outputs. So this is gonna give us the loss. We're gonna have an idea how off we are. So this is our outcome. We know that how off we are. So to reduce this loss, now we're gonna have to get into the concept of gradients. Okay, so you can think of gradients as a function of our weight. So to compute the gradient, you just need to say loss dot backwards. So I'm just gonna say function of our weight and bias. Okay, so to see the gradients or the derivatives of the weights, you can say print weight, and you can say print weights dot grad. I think I can say derivatives. Yep. Similarly, you can do the same. You can get the derivatives of the bias. So I'm gonna go into too much detail into what these values they mean, and you will be able to understand them in more detail. So for me to explain that to you, let's go to a whiteboard and let me just explain to you these concepts. So the main goal, guys, is that we want to find, right? The main goal is to find the weights or biases that actually minimize the loss. So that's the goal. Why we're computing gradient. So calculus tell us that gradient essentially indicates the rate of change of the loss. So we can use this knowledge to say if we had a loss and we had weight, right? And if we have something like a positive gradient, then we know that, okay, if we have a positive gradient, then we know that we need to decrease our weight because this is going to give us a minimum of a loss, right? If we have a negative gradient, our gradient is descending, right? If we increase our weight, then we can definitely get to the local minima. Okay, so that's the idea. So the numbers that you saw that I'm going to show you in a minute that we had, which also known as derivatives, so they are the ones that actually help us to kind of like know which direction we should take to minimize the loss. So if it's negative, we just know that, okay, we need to increase the weight. If it's positive, then we know that, okay, we need to decrease the weight. So the goal is to get here, right? And then I'm going to introduce another concept called learning rate, the pace in which we should take to get here. So if we take small steps, right, we can get here. But if we take like huge steps, then we can actually pass this point here. We can find ourselves somewhere around here or somewhere around here, right? So, but I'm going to get into too much detail, but that's the point. So that's why we needed those derivatives. Okay? So I hope you guys were able to understand this, but we're going to get into too much detail as we code it along. Then probably this will solidify your understanding. Okay, guys, just like I explained in the whiteboard, that whenever we have a negative of derivative, meaning that we're descending towards the gradient, so what we need to do is that we need to increase the weight. But if we have a positive, so what we need to do is that we need to decrease the weight. So how can we do this, right? So just to kind of like remind you of the objective is to find the weights which minimize the loss. So the derivative actually help us to know how we should actually kind of like change or adjust these weights. Okay, so don't forget that. That's the main goal. Okay, what we're gonna do now is that we're gonna use this knowledge whereby we're saying that, okay, the negative, we know that we need to increase the weight. So how can we increase the weights? That means we can use a technique whereby we subtract this by the weight. So when we subtract a negative is going to give us positive. So it's going to increment, which is what we want, because whenever we have a negative of derivatives, we want to increase the weight. When we have a positive, we're going to subtract it against the weight. So this is going to actually subtract the weight. So this is fine. But that's what we're going to do. Then we're going to introduce the concept of learning rate, whereby we're saying that we're going to take the small steps as we decreasing, so to speak. Yeah. So we're going to do that. Then what we're going to do now, since we adjusted our weight, don't forget, what we're going to do now is that we're going to call that function, which is going to be MSV. Then we're going to call our model because we have new weights. Then we're going to pass in our inputs. Okay. and we're gonna pass in our outputs. Okay, then we're gonna have a new loss, and we're gonna see what's the loss now. Okay, we see this has improved because this is what we have. You see, it was at 11,000, but now it's around 9,000. So this actually works. So you can imagine that we can do this in a for loop so that we can make sure that we minimize this, right? We can keep on doing this like iteratively, right? And we're gonna actually get the smallest loss, and you will see when I show you the predictions, we're gonna be close. Okay, so let's do it. So now guys, we're gonna go through the entire data set, so for a specified number of times. So we're gonna introduce the concept of epoch. So you can think of this as like we're saying that we wanna train our model probably like 100 times on our data set. So by doing this is that we actually get to reduce the weights every time our data set go through the training process. So that's the advantage of epochs. So we're gonna say for I in range of 200, meaning that we're gonna go towards this 200 times. So we already wrote this from scratch, I think, as we were doing this, all of this. The only thing that I didn't explain is that every time as we loop, we want to set our gradient to 0 so that they don't increment on one another. So we starting from afresh. That's why we're setting the gradient to 0 here. So in this meantime, I'm just gonna restart and run all, and we're gonna take a look at our loss. So it's literally still the same thing. You kind of like getting the prediction, calculating the loss, calculating the gradient, then you updating the weights, then you set your gradients to 0. That's it. Then you're gonna calculate the loss. Look at that. The loss now is 295. So now the exciting part. Let's look at the predictions, and let's look at the outputs. So we said we're predicting t-shirts and jackets. So let's look at this. So I mean, like, it's not bad, 19, 20, 41, 50, 36, 30. I will say it's not, given that we just created this data set randomly, and probably even the relationships are not correct, but I still think that it's not bad. But yeah, guys, that's the concept around gradient descent and linear regression. I hope you guys learned a lot. I'll try to push more of machine learning series. So stay tuned. Thanks, guys.